Well, good afternoon, everyone. Final session of the day. We have Mario and Andrew on stage to speak about DevOps, the Amazon story. Please welcome them.
Good afternoon. Sorry you have me for your last session. I know there's beers after, so I'll try and make it as quick as possible and as painless as possible for you as well. So my name is Mario. I am a solutions architect in the UK public sector, and I look after central government. With me, I've got Andrew. Andrew's the same. We both work in the UK central government team, and we are solutions architects. So the big question is, why are we here today? Good food, good beer, the weather's amazing, good company. But why I'm here is to talk about DevOps. And what is DevOps? And then I'm going to throw a little bit of a story on how Amazon transformed their own business to be more agile on the way they deliver their own products to the customers. And then Andrew will go through some of the services that it can help you as a customer to go through your own DevOps transformation within your business. And it depends how much I talk, I might leave Andrew some time to do a demo as well. We'll see how we go. Again, my aim is for you to be able to walk away from this session to understand what are the parts of DevOps, how you can deploy DevOps within your own organization, and what tools we have as AWS to help you with that process as well. Just to let you know, this is not a technical session. There's a very small part at the end, which is Andrew's part with a demo, and that as well is a very high level technical design. It is not a technical session, this is more about management, as the track says, and I'll explain to you why in next slide. So, we all know that innovation has become a must within business today. If you don't innovate, you fall behind. If you fall behind, bye-bye customers. So, it doesn't matter how big the size is, it doesn't matter what kind of brand you are, it doesn't matter what vertical you come from. You might be commercial, you might be public sector. We have seen now that startups can take on huge giants with little and funding up ahead of time. There's demand from your customers to make sure your downloads are available with a click of a button within minutes. And that's available for millions of users at any given time. And your ability to move fast is paramount to the way you fight disruption or cause disruption in the market. Right? So why does DevOps matter? So there was a study from Puppet a couple of years ago, and they have said that high-performance organizations that utilize DevOps, they're able to deploy 30 times more frequently than other organizations. At the same time, they have been able to cut the lead time by 200 times. Those organizations have been able to experience 60 times less failures, and when they do experience failure, they have been able to recover 168 times quicker. Right? So, a lot of people say to me, does that mean that I have to build a new application? Because my application is already there, I don't have the time, or I don't know how to move to DevOps. DevOps does not apply to new applications, or to greenfield, or to anything else. It applies to all applications. If you have a legacy application, you can still implement DevOps in that method. All right, oh my God, DevOps. Where can I buy it? Does Amazon sell it? Right. So it's very important to understand DevOps is not a tool set. It is not something you can buy from somebody. Or it's a combination of cultural philosophies, it's business processes, and there's of course the tool sets. These tool sets, what they do is they support the culture change. They support the business drive, but they are not the fundamental part of DevOps. The fundamental part of DevOps is you, as a business, have the appetite to move to DevOps. If the appetite is not there, you won't be able to move. Doesn't matter what tools I give you, doesn't matter what people will bring in, there has to be an appetite from IT and non-IT business organizations to move forward. All right, so let's dig a bit more into the DevOps practices. So, first of all, as the word says, DevOps is about removing barriers from the old traditional teams you had in the development team and the operations teams. But bring them together, you're improving both productivity of your developers and the reliability of your operations teams. So, at the same time, that team becomes one. So they share the same ownership. They have the same responsibilities, and they are driven toward the same goals. And those are better services for your customer. At the same time, they are all, the quality assurance and security teams can combine and they can work together to what we call DevSecOps. Right? DevOps does not mean security goes away at all. And I'll talk about that in the next slide as well. In some organizations, we have seen that, and to be honest, most now, they don't have a dev team and ops team anymore. They have one team. Again, it takes time, and I'll go through the Amazon story as well. It's not something you can do overnight. You just don't wake up and say, okay, I'm going to bring DevOps to my team now, and that's it. It takes time, and it's not an easy process either, I'm not going to lie to you. So, next part is, to be able to be successful in DevOps, you need to start breaking down your application to smaller, decoupled services. Because if you have a huge monolithic environment, DevOps becomes difficult, because you can't deploy fast enough. You will deploy once every 6 months, once a month, whatever it is. That is not innovative. That is not DevOps. That's the old traditional way of doing application development. So, one option that customers have is to move to a smaller decoupled services, and that's what we call microservices. Again, microservices doesn't mean it has to be containers. Doesn't have to be containers. Containers are amazing because it makes it easier for you, it's a smaller footprint, but microservice does not just mean containers. It means a lot of things. But the most important thing to understand is to start using services that have only one role, and they are isolated from everybody else. And by doing so, you remove the blast radius from other application teams. If your application breaks, or if your service breaks, it won't affect everybody else. And it will be much easier to troubleshoot because you know who are the owners. If it's a monolithic environment and something breaks, what happens? Everything breaks. At the same time, is like if you have a combination of microservices and you have increased release frequency, you start to experience other challenges. And those are the vast number of deployments might become a bottleneck. If you don't deploy a pipeline, which is what DevOps is really about, you will have issues. And we did that as well. Now, again, I'll go through the story of AWS. So, DevOps practices are all about continuous integration, continuous delivery to solve issues when you deploy services too quickly. But that's what you want to do. The aim is to deploy too quickly. At the same time, infrastructure as a code and infrastructure automation is crucial to develop DevOps. If you don't have the infrastructure to develop to support your scale, it won't work. You can't do it with your traditional physical hardware. You have to move into a cloud type technology, or you have to have a vast number of infrastructure to be able to support your DevOps transformation. And then infrastructure as code, as you can see on the slide, this is Amazon's own. It's called CloudFormation. I don't know if you're familiar with it, but it achieves three things for businesses. First of all, it will bring cost reductions. And I know you're saying, why? It's just a tool. What will it do for me? By having infrastructure as a code, you will allow your teams to focus on your business part and not seeing them building infrastructure or building hardware. You can get infrastructure as a code and repeat the same infrastructure as a code multiple times to different environments. Test, dev, pre-prod, and then prod. All that with a click of a button. That way you can get your engineers and your team and your developers to only focus on one thing. Make the service better. At the same time, is speed. As I said before, is being able to move from test to production with a click of a button. It's fundamental for any business. And last is your risks. Because your infrastructure is exactly the same, doesn't matter if it's Stage or anywhere else you do, because it's infrastructure, because it's code, you will be able to eliminate any risk or errors you might have on the infrastructure level. And of course, by innovating very quickly, you need to be able to have aggressive monitoring. You develop very quickly, you have deployments every 1 hour, 2 hours, whatever you do as a business. But if you don't have what we call a feedback loop, you will never know. So you have to start bringing automation in regards to the way you do login, the way you do monitoring, and be able to do self-healing on the application and the infrastructure level by using DevOps methodologies. So let's quickly summarize some of the benefits that DevOps brings to you as a business. First of all, improved collaborations. As I said before, by having one team and they're having the same ownership, the same shared responsibility, and the same goal, which is end customer and improvement of the service, you have overall improved collaboration. It reduces inefficiencies within the service, and it reduces times to go to market. Rapid deployment of releases can innovate you, and it can improve your product faster. It can meet your customers' requirements much quicker, and by having a rapid delivery, you can even fix bugs quicker. Reliability is, again, by using the right tools, continuous deployment and continuous integration, you can test every phase of your cycle. Even if it comes to just infrastructure as a code, that can always be checked first before being delivered. Security. A lot of people in public sector, if you don't mind me saying, they think that by moving to DevOps, there has to be a sacrifice of security. That is not true. They work very well together, and if you have the right tools, it can even be even more improved security by automation by using DevOps. You can use tools like fine-grained controls, compliance policies, and configuration management techniques to always stay within governance. Why? Again, because your infrastructure and your whole environment is code. It's very, very easy to apply controls into code when it's not easy to do when you buy hardware. Again, scale. You want to scale. You want to scale very quickly because you want to innovate. You want to behave based on what the market demands are. So again, you can operate and find your whole infrastructure, your application by DevOps very, very quickly, and again, with reduced risks. And again, that's just very similar. Speed and rapid deployment is very similar. But again, the end goal is by having that speed you need, you can innovate quick and you can address customers' requirements. All right. So let's have a little bit of fun and look at Amazon story. This is a life story, and you probably appreciate that even we make mistakes. We're not perfect. I never said we are, but it's nice to know that the story went through, the transformation went through, the mistake we made, and how we will be able to help you through that as well. So, after 2001, Amazon was running a huge monolithic environment. Huge, as you can see. And not everybody did. And then we realized we were not innovating. We had robots within our fulfillment centers, being completely automatic, but our code was manual. So what was the point of us having the robots and all the innovation we had within the fulfillment centers, where our code and our application delivery was so manual? So we decided to start bringing microservices and decoupled services within the environment, and split the teams down to 2 pizza teams. Now I want to ask the audience, has anybody heard that term, and do you know what that means?
Small teams.
Small teams. Or small pizzas?
No, small teams.
So, again, I did the same presentation in London, and somebody said to me, the pizzas in America are very large, you know. I've been in Italy, they're very big in Italy too. So again, so it's not that the size of the pizzas, it's just demonstrate what we're trying to say is we try to make our teams that small enough that just 2 pizzas will feed them. All right? That's why I'm not DevOps. I eat one by myself. So, all right. So again, please note on the top it says 2001, and we finished in 2009. All right? Which is why I said it is not you just wake up one night and say, I'm the manager of the developers, I'm going to do DevOps tomorrow. It's going to happen. It doesn't apply that way, guys. It's not as easy as such. So, and that was phase 1. Right? That was 8 years to do phase 1. And to be fair, Amazon was not as big as we are today either. So we moved to microservices, we decoupled services, we built the pizza teams, we realized we had everything went well, we improved, we had much quicker software releases, but we realized something was still not working. Again, I will interact with you guys, keep you awake. What do you think went wrong? Any ideas? Too many pizzas, that's good. So what happened was we opened the floodgates. We opened the floodgates on releases, but we didn't have the infrastructure or the deployment method to be able to accommodate that new methodology. So, again, we wanted to find out what's going on. Why was that the case? We follow the best practices, which is DevOps, is microservices, pizzas, whatever it is. Still, why is it not working for us after 9 years or 8 years? So we ran our own study. We ran a study internally to find exactly what's going on. So we sat down with all the development teams, the operation teams, the DevOps teams, the analysts, trying to find out exactly what's going on. And we were really shocked on the findings we had. So, to run a code, it will take minutes. And then, to deploy and build the code, it will take days. And then from build into test, more days. But really, the development and the team that was working, they were taking seconds or minutes. So what was going on? All right, so the way the teams collaborated, although they were DevOps, they were doing manual tasks. They were sending tickets to each other. They were asking for deployment times. They were asking for, hands-off tasks. So instead of building, they were just still collaborating on a manual level. And that's not DevOps. So instead of so we saw a whole deployment, although it's still quicker than it was before, months, it was still taking weeks. So we wanted to bring it down to it says hours there. To be fair, now it's seconds the way we do it. But we wanted to bring in the first goal as a business was to bring it sub-hour to be able to fulfill the whole DevOps cycle. So we said, what's the tools available for us? There wasn't any tools, so we built our own tools. So to speed things up, we just created our own tool. It's called Apollo. I don't know if you've heard of it before. So the aim of Apollo is to be able to bring all the parts of the development cycle in within a click of a button. So what I want to do, the developers will go and create pipelines. In the pipeline, they only deploy the software into one server, just one server. You press a button, and it will do every single stage of the DevOps cycle automatically for you. So what I mean, it will go into your source repository and upload the code. From there, it will build the code. From there, it will test the code. Please, always test, all right? And then, finally, it will deploy to stage. Not production, stage. When you're happy with the stage environment, it will progress to production. Okay? So, that wasn't possible before, but with the pipeline, we were able to achieve the results we wanted. But at the same time, although faster delivery was our main focus of this project, we realized that there were other benefits as well. So we're sure that the code, because of the gates that the code goes through are always the same, the quality of the code increased dramatically. And the way we were able to fix bugs was dramatically improved. So, 12 months later, so now we're 2010, all right? We're still going through the cycle of learning as a business. We did a survey, and we saw, now with Amazon, we had thousands of service teams. There's two Peter teams within the environment. We were building microservices very, very quickly. We were practicing continuous delivery, and we had, and we still have, many environments, staging, prod, beta, whatever you want to call it. But the most important thing is, within those first 12 months, we had 50 million deployments, software deployments. Now, that was in 2010, all right? If you convert 50 million to the seconds per year, it comes to a deployment per second, right? Now, again, we haven't given any numbers, and again, last time I heard, we're doing close to 3 or 5 deployments per second, all right? Well, we didn't stop that one. Yes, one more to tell is we did a survey. Every year we've done a survey with our developers team to make sure that developers are happy. Our developers are what makes or all the teams make Amazon click, but again, our developers are special for us. So we run surveys every year to make sure that our developers are happy and they have the right tools to provide the product we do. And they always say, if it wasn't for Apollo, we wouldn't be successful as we are today. Now, I keep saying Apollo, and I use that word is because the way Amazon works is, we saw Apollo was very successful for us as a business. So what we did, we make it available for our customers. We call it code deployed. And then we'll talk about those. That's the way Amazon works. We see something that's very successful for us, and the volume we are, and the size we are, that means it will be available and successful for our customers. So most of the services we build is either come from customers' feedback, or it's coming from internal testing through the volume we are, and how aggressive we are, and how picky Amazon is, and that's why we pass back to our customers. So, great Mario, you sold me the dream. Can I buy DevOps from Amazon.com? Is there something I can buy in my basket? No, I've talked about this before. It is not easy at all. I'm not going to lie to you. It's not something you can do very quickly. It takes a lot of time. But if you have the right attitude as a business, you will be able to do it. And again, we can help you then. At the same time, DevOps means different for every company. Yeah? You might have a very small requirement to innovate. You can still deploy DevOps, but you might not do it on the level other companies do it. Yeah? So don't think you have to go out there and build the 2 Peter teams. Doesn't mean you have to do that. Yeah? But at least start moving to more agile methodology. And the last thing I want to say before I hand over to Andrew is, again, I want to highlight again is, DevOps is beyond technology. I have worked with many CTOs and many CIOs. They come to me and say, I'm ready for DevOps. I want to buy a tool. I said, but have you spoken to your business? Have you spoken to your non-IT people, your IT people? I mean, why do I need to? It's technology. It's TCP/IP. It's coding. It's Java. I don't need to talk to anybody. It is not. Please understand, DevOps is all about business and cultural changes. Without those, if you don't mind me saying, you might fail. So what I'll do now, I'll hand over to Andrew, and Andrew will go through very briefly about our AWS services that it can help you. They're called the Code Suite. And then hopefully, how we go with time. It will do a quick demo. Thank you.
Hi all, I'm Andrew, as Mario said. I'm a solutions architect in the UK public sector team. I'm predominantly responsible for helping our central government UK customers in doing things on the AWS cloud, wide and varied things. There we go. As Mario's mentioned already, we have a number of tools that can help you on your transformation to a more DevOps methodology inside your organizations. It's important to realize that these tools aren't the things you go and buy that give you DevOps. They aren't, as Mario said, they aren't the be-all and end-all of DevOps. They're the tools to help you with your processes side of things in your business. So we have 5 major tools that exist so far. I'm going to start the second one, which is Code Pipeline. The comments that Mario made about pipelines and how you push your software through a pipeline to improve the quality of it and also to make the deployments faster. Effectively, Code Pipeline helps you do that, and we'll come back to that in a few minutes' time when I do a demo. We'll see how Code Pipeline actually looks and how you can see the stages of your infrastructure deployment, software deployment through your infrastructure through Code Pipeline. We have Code Deploy. Code Deploy is effectively, as Mario said, is our version of Apollo that we give back to customers like yourselves. It helps you to deploy your packaged built applications that your developers build onto your EC2 instances or wherever else you're running them. We have Code Commit, which is our managed Git-based source control repository. Developers who are sitting all day at desks, working together, hopefully building an application in a way that's agile and fast, will actually commit the code to Code Commit. You may already use a source control repository. There are lots of different flavors of them out there. And finally, there's Code Build. Code Build is a tool which builds your application inside some infrastructure and is extremely useful for testing. So we'll come back to using that as well, and also Code Commit. So software release steps are quite interesting. If we think about how software releases start, we start off with Code Commit. That's where I'm a developer. I'm sat down at my desk. I'm take a story off the backlog or whatever, and I've started to write some code. I then need to share that with my team. It's not a great idea for me to write all that stuff, put it into a zip file and email it around my team. Things get lost. It's a mess quite quickly. If you've ever worked with word processing documents and sharing them around in an email chain, that's a very common analogy. It's the same thing for developers. We don't like doing it. So code commit my stuff to there, and off I go. After I've done that, I can take my application that's been built in code commit. Code commit, or a source control repository, becomes a single source of truth. That is, everything about that application lives in code commit. If there's a change that someone has made that does not live in code commit, it is not a change that's acceptable. That should be the true source of truth. If you want to make a change as a developer, your change needs to be in code commit, or Git repository. When we're in code build, we take that entire repository and we effectively do a lot of testing on it. We'll see how that works in action in a few minutes' time. And the testing can produce various outputs. So one thing that's really useful for is sharing the results of tests with everybody else. If you commit, you can set code build up quite quickly to check for changes to your Git repo and then build automatically out the back of that. That means that you can commit, you can make your change, commit that, and then it'll build, and hopefully the tests pass. Then we've got tools where we can integrate with third-party systems, and they can integrate back with others as well. So this is really useful if, for example, you use BlazeMeter or any other testing suites out there. We can integrate code pipeline quite quickly with BlazeMeter and a variety of other tools in order that you can go and test using lots of different ways that your application works. And really the test stage would actually happen inside code build as well. So the two sort of married together. And finally, once your test pass, or if your test pass, tests don't always pass, hopefully the test pass in this example, and we can start to deploy your application. And this is the stage at which we will start to put it onto the development environment, or you might go into your staging environment and into your production environment. So in effect, this last section, this deploy section, happens circularly until we've got to production. There are methods for putting manual approval gates in there, or just automating the whole lot, and that's a whole conversation you need to sort of consider yourselves in your organization if you're doing this. So I said there were 5 services. I've gone through 4 of them already. Oops, sorry, no, I've slided ahead already. So we can put these services together in code pipeline. So code pipeline can, for example, have a stage which says go and call off to code build, and code build will then do its thing and pass the stuff onto the third-party testing suite that you may have enabled with code build, and then it can pass it on to wherever. And the pipeline is effectively a list of stages that run through in order. What I was going to say a second ago was that we have a 5th service, which you saw on the first slide. The 5th service is code start. If you're just getting started and you don't know how these services work, in which order they should go, do I put code commit straight to code deploy? The answer is probably no in that example, but then code start can set the basics up for you. It's a service, you go in, you say, you answer a few questions about how your environment looks or how you want it to look, and off you go. That's how that works. After that, it's customizable, and you can reach into each of the individual services afterwards to change things around if you need to, as your needs grow. And finally, how does this work with the rest of the AWS stack and our other development tools at large? So we've considered the first 5 there on the left-hand side: code commit, code start, code build, code deploy, and code pipeline. Mario's mentioned already that CloudFormation exists. There are other services, OpsWorks, which is a managed and hosted Puppet or Chef configuration management tool. And there's AWS Config, which helps you do governance and security requirement analysis on your infrastructure at large. We've got monitoring and logging tools such as CloudWatch and CloudTrail. For most, or for newer AWS accounts, CloudTrail will be enabled by default. You can turn it on if not. A service which is really useful for logging API calls. And finally, for simpler applications that you want to get up and running and just not have to bother worrying about the infrastructure behind them, we have Elastic Beanstalk. Elastic Beanstalk can take an application written in a number of different languages, put it up into the AWS cloud, and runs the infrastructure behind it for you to some extent. It's a great starting place if you've just got an application and no real knowledge of how infrastructure will work on that. So, next thing I'm going to do, I think, is a demo. And I'm going to demo today a few of our services together. You'll have seen this slide a few seconds ago. We're going to start off by taking a source repository in code commit. It already exists. I've got a few commits in there. We're going to make a change to that repository. Once we've made our change, which we'll walk through, then that change will be committed and shoved up to code commit, at which point code build will automatically kick off because it's seen a change. And it will go through a build pipeline, which we'll look at as well. And you can see the build pipeline at the bottom, that's how that service interacts with Go Build, and it'll do a third-party test. We won't, however, be doing code deployments at the end. The deployment happens automatically, as in this example, as part of code build. You could, in theory, as well use code deploy to make the demo fit in. I'm going to do it with code build instead. The third-party tool I'm going to use here, by the way, is HashiCorp's Packer. HashiCorp's Packer is a way of declaring what an AMI, or an Amazon Machine Image, looks like. An Amazon Machine Image is effectively a snapshot of an EC2 instance, or a server that you're running. And you can then redeploy that over and over again. That's a common way for building infrastructure in the AWS cloud. That means you can quickly deploy repeatable, reliable infrastructure. It's not the only way, but it's a common way. So, with a bit of luck, this will work. Right, so I can pop over here. Okay, so we've got the AWS console. No, we don't. That's a good point. We don't. We have a very messy looking. Oh no, I don't. Hang on a second. There we go. All right. So if we skip past the AWS console onto a very messy looking page. I, as a developer, love these types of pages. Terminals, I love them. They're great. So I want to make a change. My application here is pretty simple. It's not particularly interesting, if I'm honest with you, but it's simple. I, as a business, have a need to have a HTML page that shows a word or a sentence in a web browser.
Can you guess what the word is on that page?
Hey, they've seen it before. They've seen it before already. Ah, it's not a surprise. Well, so yes, literally, it's a hello world page. Oh, if you can't see it back, let me make it a bit bigger. Sorry about that. There we go. Okay, so hello world page, and that's what my infrastructure currently shows. It's not particularly interesting. I want to, if you saw that in a web browser, you would just literally see a bit of Times New Roman text with hello world. It's of no business value whatsoever, but it's a simple example. Now, I want to change hello world to be something more contextual, something more specific to the room perhaps, so I might say hello Brussels, because we're in Brussels. And at this point, I go and I write my file. I've written my file, and I can now go and add that file. Oops, right, I can go into a status to check that our file has changed. You'll see that we've modified that file just there. Off I go and add the file, and you'll see that the change is that I've changed the word world to Brussels. So I'm happy with that change, and I'm going to go and commit it. At the end there, I put hello Brussels in quotes. We'll come back to that in a second, you'll see where that is used. But that's a message to say effectively what I've just changed. It's a really useful summary message. Otherwise, developers will put all sorts of commits up with no real idea of what's being changed, and it's a bit of a nightmare from a process and perspective. So off that goes, and at this point, I do a push. Push is the part where we're going to send that up to CodeCommit. Off it does its thing. Now, here is an interesting point I want to just point out. Much like a timeline would be, you'd have a specific point in a timeline for certain events. Git repositories like CodeCommit have a similar concept. So what we do is we start out at one particular point in time, and we give that a unique ID, and then when we change it, we go to a different point in time. So we've moved from the point in time called 498AATE to this new point in time. And we'll see that change reflected in CodeCommit in a second. So I've pushed that up, and that's gone off to CodeCommit, and I'm running all this in our London region, by the way. So all that's up there. And I can go to the CodeCommit console. And the CodeCommit console has a repository, and inside there are a list of commits. And you'll see there that I have just authored about a minute ago a commit with that unique ID we saw a few seconds ago. If we go into there as well, CodeCommit can give you a visual representation in the browser. So effectively, you've just seen that in my terminal window, you're now seeing it in my browser. At the same time, what's actually happened behind the scenes is that we've picked up on something that we've pushed to CodeCommit, and Code Pipeline has gone and started, or should have started. And you see it's actually gone past the 2 stages we've got so far. So in all likelihood, this pipeline will continue to run and finish before I finish speaking. So what I'll do is I'll run through from the start, and by the time it's finished, we'll hopefully stop speaking or thereabouts. Code commit has noticed a change has happened. I've shoved up the words hello world, and I've changed them to hello Brussels, and I've pushed them up to the AWS cloud, and they're up there in a code commit repository. Code pipeline realized that something had happened and has then gone and cloned the repo. Cloning a repo is grabbing the entire source of that application you've got, bringing it down and making it usable by something, in this case, code build. Once it's done that, which it's happy with, and successful, you'll see that we've got code build down here. We've got a build stage running code build. So if we go into code build from there, if this works, this is a particular code build step running in a container, in EC2. We have our job at the bottom here, a variety of parameters you can set about where your build runs and how it runs and various things. I'm not going to go into those right now. And you'll see at the bottom that our build logs are going away, and that's running happily in the background. We've got a variety of steps here. So while we wait for this to run, in effect, what it's going to do, a slightly technical thing, it's going to create an EC2 instance using Packer. It's going to install a load of updates on it, because it's a good practice and good infrastructure hygiene to do so. It's then going to install a free and open source web server called Nginx, and it's going to move the file we just amended, the index.html file, into a location where Nginx can pick it up, and away it goes. And that should mean that we then get an instance out the back, and it should spit me an IP address out in a second that we can then go and use in the browser to see hello Brussels whilst it's doing that. So currently waiting for that to happen.
So what we... Thank you. 1, 2,
So it should be a second or so.
So it doesn't matter. I've got a laptop. So it's very important to understand that Andrew did not deploy any service. Andrew didn't do any testing. All Andrew did as a developer, he went and changed the famous hello world, to a hello Brussels. And through automation and triggers, the whole process was automatic. Again, the mistake we did as Amazon 2009 is a lot of developers made a change. But what happened after? Didn't know. So by having a pipeline and making it automatic, will make, okay, this is a very small example, but you extend your pipeline if you wanted to, and based on the triggers you want, you can automate the whole process. So what I've seen customers do is on the pipelines, for the staging environment, everything from source to build, to test and deploy, if it's for a staging environment or a test environment, it's completely automatic, completely automatic. When it's time to deploy to production, after you become familiar and comfortable with the whole infrastructure, you might have a method, but the last part of your step, which is the deploy, you might have to get approval by a human. So what Code Pipeline can do, I finish all the stages, and now I'm waiting for Mario to approve the final stage. It is a bottleneck. Let's face it, guys. It is a bottleneck.
He is quite easy.
I'm very slow. Yeah. So it is a bottleneck because you expected somebody or a team to do it for you, but you need to. We all appreciate, to get to production environments. Some people don't feel comfortable by making it automatic. You will get there eventually. I hope you will. But some departments, we all respect that and appreciate that. It might not be something you want to do from day one. But again, I just want to highlight the pipeline doesn't have to be completely automatic, and it doesn't have to be completely manual. You flex it the way you, as a business, need to do it. You still going?
No, it's finished.
Hey.
So I wanted to point out we have actually, mic on. Here it is. There we go. I wanted to point out that the code pipeline itself does actually, so Code Build itself has actually done a bit of a testing stage for us as well. As Mario said earlier on, not testing stuff isn't a great idea, so if we test everything. Packer does contain a way of testing the file that actually builds all this. And that stage it runs very quickly, and it was run just there. So you should be able to see it on your screens now and make it a bit bigger. So it did go and run to make sure that the file is syntactically, let me move that up. It's syntactically valid. There we go. So, all that's done. You'll see at the top, we've got our stages here. They've all gone green, they've all succeeded, so everything was happy in this example, and it's complete at the bottom. And my example here, if we make that go to the top, then we should see,
One more thing to add as well here, while Andrew's talking is, although you see this output on your screen, you probably say that's not sufficient. Where's the logs? If you see the top that says view entire log, if you click that, you will be able to see exactly the whole process, and you will be able to do whatever you want with it according to that. So what you're seeing on the screen is not the log. It's just a simulation of the log, but the log is available for you as you see here.
Yeah, we take the log and dump into CloudWatch. I said integration just works out of the box. And then you can query CloudWatch if you wanted to find out what you wanted. These logs that are running here, you can see on the screen, are exactly the same ones we just got in the other screen back here. So my automation, to make this a bit simpler, has spat me back out an IP address for the EC2 instance, which is started up in the background after all the tests and everything deployment-wise happened and finished. So in theory, so here we go. In theory, there we go. We have a page which now says Hello Brussels. So from the case of taking, what, 5 minutes or so, or even quicker, I talk a lot. We've gone from having it need to make a change, to having made the change, to having it pushed to a place that's centrally available with a highly available repository behind it, so that members of my team of one, we could do with a colleague, Mario, can get access to my stuff. We've gone through to building that application, we've tested it, we've deployed it, and we've integrated code build, code pipeline, code commit, and a variety of other AWS services in the background, such as IAM and EC2. And now this is running on an EC2 instance on the internet. So there we go. That is a very simple deployment pipeline using AWS development tool services. Thank you.
So again, I wanted to recap as well. It's the third-party tool integration is available for you. So I've got a lot of customers say our teams already know a particular tool for the DevOps, being, let's say, Jenkins, whatever you want to use. Again, we have integration for those tools. You don't have to choose to know the whole pipeline just to use our tools. You can start bringing your own tools to build the pipeline, right? So I want to open the floor now for any questions you might have. We have a microphone that pass over, or you can just go and have beers, whatever you sick of my voice, I can understand.
Is there expectation that you will supply testing software where there is now third-party tooling in the future as well?
Sorry, I didn't hear you. Maybe you did on my and the light. I'm really bad. I can't look at you. Sorry.
In the test phase, you got now third-party tooling.
No, yes, actually. So, is there any plans in the future of us releasing a testing? So, unfortunately, I can't disclose our roadmap at the moment. Again, I'm more than happy to talk to anybody one-to-one, but the roadmap is something that we don't talk about in public. So, next question. Yep.
Thank you for the presentation. Did you have support for code commit to, or maybe the pipeline, to deploy dynamically a different environment through whatever branch where I push my code?
So do you mind if I take that over? So, or maybe not. It's your laptop. Give me a second. So what you can do in the pipeline, that's why I like not using my laptop. Andrew, you might show. So in the pipeline, code pipeline, you can define different stages. So you can say the moment code commit triggers, it will go and start building. But it doesn't have to build in one place only. You can build across multiple environments. You can build it to stage, test, prod, whatever you... Sorry. Whichever you want to go. So it's not a one-to-one relationship, it's one-to-many. So again, it's the most important thing is to have a repository for your code. Once the code is there, and based on the triggers you define within your pipeline, you can go anywhere you want it to go. Within, of course, the pipeline. Is that answering your question? Is that what you were?
Even on the name of the branch. For example, I could trigger
a different branch.
Based the infrastructure and the different environment could be dynamic, totally dynamic, based on the name of the branch, for example.
Probably.
You can do. You can do that through code build, for example, and also through code pipeline. You can pass parameters and arguments in. I haven't done it in this example. Building straight from the master branch. The master branch, by the way, is the default branch that most people end up using. People vary these other ones if they want to, but you can do it, yeah. Just specify the name of the branch, or even the committish, and take the committish straight and build that committish at that point in time and go from there.
There's a white paper that shows, I think it goes across 4 different branches and 4 different environments. It's a huge pipeline. There's a white paper we have. Come and see me afterwards, so I can find it for you and show you how to do it. But yes, you can commit you can start building your committed code anywhere you want to, as long as of course it has access to it. So it's not locked in one-to-one.
Thank you.
Bear with us a second. There we go.
Thank you. I mentioned with your presentation, you mentioned about the DevOps. I've heard nothing about containers, containerization.
Yep.
But it's in the, I think you call it the log of the packer.
Yeah, so
a tag like a container, but how do you see that? Because likewise, I could develop my own containers and provide that to AWS and get it deployed, for example. Is that possible, or is that not part of this?
So you're asking, or so on the code build phase, we deployed our own containers to do the build for you. So you want to know if there's any way where you can bring your own containers to do that build instead. Is that what the question was?
Yeah, or
Yeah.
Can you influence what is in the container itself?
Oh, yes, you can change
Because
that.
there's nothing mentioned about container anywhere, so
Sure, so
it
in that,
confused me something.
in that container as it stands, I took the Ubuntu 14.04 base image we provide, and I took that and I actually have installed sed through apt, and I've done a few other things at the top there. It does it lightning quick, so you won't have seen that. If we can find it, we can grab you the container logs or a different tab.
I just want to show the build. So
Okay.
This is a code build. He asked you which is your provider for the code. So I'm choosing here code commit, which is the source repository. But if you see then I can choose if I can use an Amazon build container or if I use my own Docker image. So there's nothing that stops you of bringing your own image in within our ECR. ECR is our Docker image repository. And from there, you can point your build to that container.
You talked about the human intervention when you go to prod.
Yep.
Can you also elaborate on the security? Because the feedback I have from many customers is that's all okay, we've implemented it, but once we have to change a firewall rule or any change of security, then we lose 2 weeks. So what have you seen in the market as the best practices to tackle this challenge?
So the best practice is infrastructure as a code. Whatever you change, whichever way you change your application, and let's say the application will require a new firewall rule to be implemented through infrastructure as a code, you will be able to inject that change at the same time through your DevOps methodology. So because your infrastructure now can be tweaked and modified through API calls and through code, you will be able to do the whole thing in one go. Does that answer your question? So
Yes, it does, but okay. There remains a challenge if you want double layers of security, if you want security to be independent.
yeah, okay. Yeah.
Because then you give the responsibility to the developers to make sure that they implement the right rules.
Okay, no. So that's not the way DevOps works. So overall, the way it should be working. So you have governance in place. So you, as a business or as a whatever your service is, you should have governance in place about you don't rely only on your developers to be able to be secure. Developers know they're very good at one thing, developing. The end goal for the developers to bring a service or a feature up. That's why you bring DevSecOps together. That's why you bring more teams in within your whole cycle. So a developer will do an application or will do a change, but at the same time, through infrastructure as a code, your security team will have gone through and make sure what you're building is secure. But you will have done that before you move to DevOps. You would have done through, governance, fine-grained controls, monitoring and logging, automation. So you should be concerned about security on the last stage. That's a bit too late now. You should be concerned from the first place, make sure that the governance, the policies, and everything else are being applied from day one. And of course, they can be tweaked based on business requirements, but you shouldn't rely on your developers to do that for you. But you can make it automatic. Again, if let's say I've got a new application and the application needs port 8080 being Tomcat or whatever it is, doesn't mean I have to wait months or weeks for my network team to open the firewall. It can be done through infrastructure as a code. It will go into the security group. We have security groups. It will go in and say, I've got a new rule that says open port 8080 for that application from that IP address, and it will do it for you straight away. Because you should build governance that's saying, we trust the overall infrastructure, and let's say you will be able to start putting monitoring in place. So my tools will create a firewall rule, and the firewall rule will say open port 80, let's make it easy, port 80 to the whole world. Through config, which Andrew mentioned before, it will say somebody created a new firewall rule. That firewall rule is open to the whole world, which should be straight away an alert for you as a business. But then you do a little bit more digging. The tool will do digging. But it's open for port 80. Port 80, you have approved it because it's a public-facing port to allow. Now, let's say a developer makes a mistake, and through infrastructure as a code, he opens port 22, or port 3389. 22 is SSH, 3389 is RDP for Microsoft to log into your, and that opens the whole world. That's where DevOps really works, because config will say, whoa, somebody has opened management of the server to the whole world. The developer doesn't know, he doesn't understand. Let's say for a second, he doesn't understand. Config then, through the automation, will say, that's not right. I will go and destroy that server. It doesn't matter what the developer does, because security comes first. I will blow away the server, and I will block the developer access to the environment. I've done it on a test, it was so fun. So you can do, you can do whatever you want. So don't rely on humans even for security. Humans will build the framework, they will build the governance and the policy you need to, but the humans they're not fast enough to be able to prevent those. The more humans, we are more like an IDS versus an IPS. We just look, we might be able to prevent, but we don't prevent, which is why automation will prevent it for you. Is that okay? Any more questions? Okay. Thank you guys, and I hope you enjoy your day, and we'll see you at the bar.